and welcome to another episode of 3 Videos with Nathaniel. Today, we'll now solve question 1E of MAT Oxford 2012. Before we begin, let us have a look at Coco, our sponsor. Wait, actually Coco's too shy to be put, so don't bother. So anyway, we need to find a potential equation for this curve. Okay, first things to note, the curve has 4 local minima and maxima, so that means the curve must be a quintic. So we'll mark it as one of our characteristics. Second, it has 2 touching at 0 points. As you might know, if you have a root like this, x minus 6, then you will know that it's going to cut something like this or like this. But if it's something like x plus 1 square, if this is included as a factor, then you'll most likely see this. Do you understand? Yes, now this is very easy. Now we can say that these are equal distance from the y-axis. So, and they both touch 0. So, you put x plus 2 squared, x minus 2 squared. And you can see this is much further away. Let's pick another random number, x minus 6. Well, obviously this is not going to work because if we substitute huge positive value for x, say like 1 million, then this curve will shoot up to the stars. That's why we'll need to do something negative. How's about x squared minus 1 squared? Because if we look at x squared minus 1 equals to x plus 1, x minus 1. So if x squared minus 1 squared equals to x plus 1 squared, x minus 1 squared. So there you have it. And then we pick something negative, but it's perfectly hidden, say 3 minus x. So there you have it. You have constructed a false attempt at making an equation on this quintic, and a true attempt at making this equation for a quintic. Now you might go equation hunting like this, whatever to your fancy, but whatever it is, when you want to find a graph on an equation, 1, make sure it's a polynomial to make things simple. 2, find out how many maxima or minima it has. So for example, in your function, let's say your function is only complicated, it has 11 maxima or minima, and that's for the whole real number range. That means it should be a, what should we call it, a dodecadic equation. Anyway, I'm very sad pronouncing this. Third, you have to count the number of roots. And roots can be one of 2 types. Remember we talked about this? Intersect the axis this many times. However, roots can also be quadratic roots like this. In this case, where you plan to put x minus a type of roots and x minus a squared type roots. So you can apply these roots anytime to your fancy. And in I3, I'm going to make a simulator which has add x plus a, add x minus a squared, find out how many local maxima or minima it has, stating what kind of equation it is. And then like even more free time, you can think about a polynomial naming scheme too, like linear, quadratic, cubic, quartic, quintic, sextic, septic, octic, novic, and decic. That's all. That's all I can do. Anyway, that's gonna be a really funny thing. And I hope you see more MAT videos. Goodbye!